G'day. This video is a very brief outline of simple statistical analysis. Very basic. It's the kind of introduction that you get in the first year or two of doing, I guess, real statistics at school. And a number of my students lately have been having difficulty with it. So let me explain. When you get a set of data, a collection of figures or information, unless it's a very tiny collection, like 4 or 5 figures or something like that, we usually put it into a table. And that's what I want to talk about in this video, is how to understand statistical tables. Now, I use a rather thick piece of colouring here. And I'm going to talk in particular about a table made of 4 columns. The middle two will have a total, and we'll put a heading on each. Now, this table is called, depending on the book you read or who tells you, a frequency distribution table, or simply a frequency table. And the 2 columns that are absolutely vital is a column represented by X, which is really what we call the score column, and another column represented by the letter F, which is a frequency. Every frequency table or every frequency distribution table will have these 2 columns. The scores are things like numbers. These are most common. Actually, I'll just use 0, 1, 2 and 3. And let's imagine that I've asked a small group of, well, let's imagine I've gone to a school and asked a small group of children how many pets they own. And these are the answers, 0, 1, 2 and 3. So they're the scores. That's the information I'm collecting from children. Now, the frequency would be the number of children that respond. So if I say, put your hand up please if you have no pets at home. Let's imagine 3 children say that. Put up your hand if you have 1 pet. Let's imagine we have, let's keep the figures fairly small, 5. 2 pets, let's say there are 11. And for 3 pets, let's make it really simple and say 1. The first question we might ask, there are a number of questions we can ask, but the first one we might ask is how many children were there in the class? And to do that, of course, this column is recording the number of children. We would add these up. That's why we have a total at the bottom of the frequency column, and 3 and 5 is 8, 19, 20. The symbol we use, and it looks a bit confusing to someone who's not used to it, instead of writing the word total, a statistician will say that they've added the frequency column, they've summed it up, and they use a Greek letter S for sum, and they say if I sum the frequency column, that's what I get. I'll just write it over here on the side. The Greek letter S, by the way, I've seen teachers write it like this. It's not like that. The top line is horizontal and the bottom line is horizontal. The Greek letter sigma, capital S. S for sum. Sum the frequency column. There it is, 20 children. That by itself, just those 2 columns, would constitute a frequency table or a frequency distribution table. And the concept I want to get across to you in this video and to my students is that every single column in a frequency distribution table has a meaning or a value or a job to do. Even these 2, and we'll talk about that in a moment. Let me just take you on a little bit of an aside. I'll just get rid of that. Statisticians are interested in a whole lot of measures of their data, but there are 2 fundamental measures that they're particularly interested in. One is where the middle score is, what we call a measure of the middle. And there are a number of answers to this question, and the 3 most common ones, or the 3 that we we teach in schools here in New South Wales are the mean, the mode, and the median. More on those in another video perhaps. There are three measures of spread. Sorry, I started to write the letter P instead of letter S. Three measures of how spread out the data is. Let's write those down. I hope I haven't gone off the bottom of the board. The first one is simply what we call the range of the scores. The second one is what we call the Inter-Quartile Range. And the last one, or the third one we teach in schools, is the Standard Deviation, represented by a small letter S in Greek, which is like the letter O with a little tag off the side. Letter O with a little tag. There you go. Letter sigma for standard deviation. Now, there are 6 of these, and if I wanted to find this, for example, there's a column for it, and there's a column to work out the median, there's a column to work out standard deviation, and so forth, or a number of columns. It turns out that the basic table that we teach in our schools here in New South Wales has 4 columns, and it helps you find 4 of these 6 things, or even a 5th one if you wish. These 3 and the range. Technically, the interquartile range can also be found from one of these columns. To find the standard deviation requires a few more columns, and I may demonstrate that in another video. I probably will, but not in this one. So we're going to concentrate on these 4. I'm going to answer, I was sort of tossing up which order to do it, but first I will show you what these 2 columns tell us. Because this column deals entirely with the scores, and let's say we don't even know the frequencies at this stage, we just know we've gone from 0 to 3 pets, it tells us the range, this one. So I'll put a little arrow here. This says the range, and to define the range, I get my students to actually write what they're doing. Subtract the 0 from the 3, the smallest score from the highest score, and we would say that the range of pets in that class, representing the class, was 3, from the lowest to the highest. If it was a test out of 100% in a school, if the top mark was 90 and the bottom mark was 20, we'd say the range was 70. The students were spread over 70 marks. And that gives us a bit of an idea of how spread out or tightly packed they are. If I encountered a class that had a spread of 15%, they would be extraordinarily tightly bunched. This column, dealing with the frequency, is telling us how many pets students have. And when we talk about how many, one of the questions we can ask is which is the most common number of pets, and what's the most popular number of pets. And the word for that is mode. Now, there is a magazine. I'm actually going to show it in a few seconds, but it'll mean I will have to edit the video to show you these magazines. But there was a fashion magazine when I was growing up called Mode Magazine. And in fact, I'll do it straight away. I was fortunate enough a few years ago to have people give me old copies, but they're not as old as the ones I remember. I'm a bit getting on in age, I guess. But I remember, not that I frequented women's fashion magazines or that section of the local news agency, but I had to walk past it to get to some of the things that interested me. And I couldn't help notice this magazine because it was big. It was a large format magazine. It had the word mode in large letters, and it catered in those days for the average woman. in what we in Australia would call dress sizes 10, 12, 14, 16. Not the anorexic models you see nowadays. And it had a lovely little niche. Now, I have 3 copies that someone provided me with. There you go, Mode magazine. Very large letters. I couldn't help but notice it in the news agency. And it's called Mode because it means popular. A la mode in French, according to the way things are, the usual thing. So it's quite a nice way to remember that the mode is the most popular thing. And the mode, of course, looking here, we look for the highest number of children. They have 2 pets each, so we would say the mode is 2. So that's 2 of our columns. What are the other 2? Well, the next column that I teach my students to write is to find the mean. Now, these are often, when a statistician uses the word average, it doesn't mean simply the mean. The mode and the median can be called averages. So we need to be specific. A mean is the thing we get when we add up numbers and divide by the total number of numbers. So what is the mean number of pets in the class? Well, if I said to the class of students, let's have show and tell tomorrow, and I want you to bring all your pets to school, which would be quite an adventure. Well, these poor people here, these 3 children, having no pets at home, are going to bring absolutely no pets to school. They can't. They don't have them. These 5 children have 1 pet each, so how many children will they bring to school? Well, the answer is they'll bring 5. These 11 children have 2 pets at home each, so collectively, when they come to school the next day, they will have 22 pets. How are we getting these figures? We're multiplying these, because if 11 children have 2 pets, we're going to have 22 pets. If one child has 3 pets, you go 1 times 3 is 3. If there were 7 of these, there'd be 7 lots of 3s, 21. So the column, because we're multiplying these, we call this column the fx column. F times x. That's rather simple, isn't it? And this is recording the same items, if you like. If this is studying pets, this is studying pets. And if we total this up, if we add this up, so if we add up the fx column, we get 5 and 3. Oh, this works out well. 5 and 3 is 8. We get 30. Now, I just randomly chose these numbers, so that's not bad. We get 30 pets. So we've got 20 children in the school, in this class. They've brought 30 pets to school. What is the mean number of pets? Well, the mean is always easy to work out because statistically we say we divide this total by that total. So once you've actually got the totals, this is all we're interested in for the mean. And I'll write it. We add up the fx column and we add up the f column and divide them. And we get 30 divided by 20, which is 1.5 or 1.5 pets. Not that we wish to divide them, but there we go. And we would say in common language, on average, the children have 1.5 pets each. So I hope you can see that already we have 3 columns now, and they're identifying 3 bits of information that are of interest to us. How spread out the data is, where the most common or popular bunch of data is, and what the mean is. Now this last column is used to find the median. And to do that, we use a rather neat trick. You know, I hope you know what a median is. The median is when we list all the data out. I'm using crosses, but if I actually use the numbers, perhaps I should do that. I don't want to write all 20 of them out, but if I had 3 zeros, 0, 0, 0, followed by 5 ones, 1, 2, 3, 4, 5, followed by 11 twos, you get the idea. I could write all the data out. Now for 20 that's not too bad, but if I had 88 or 275 or 3,716 or 26,000 lots of items of data, this would get extraordinarily tedious. Now, for a small number, it's quite easy. The median is simply the middle number. It's a measure of the middle. How would we find it? Well, if this was all our data, now I know it's not all of this, but if this was all it was, we would have 2, 4, 6, 8, 10, 12 numbers. We would divide it in half, which would mean 6 numbers here and 6 numbers there. So 1, 2, 3, 4, 5, 6. And then a little divide there, and 2, 4, 6 on that side. So we would say the median number would lie between the 1 and the 1. And obviously it's 1 if you average those two. We'll find the mean of those two. So that's where we find the median number is in the middle. How do we manage it with a really extraordinarily large number? Well, what we do is we follow this sort of procedure. We accumulate the frequency column. Now the word accumulate means to gather up. So we call it, I suppose we could have called it the accumulative frequency, but we call it cumulative frequency column. So we accumulate this. I get my students, when I first instruct them, to point to this column and actually use their finger to work down as they write these numbers. Because if they don't, I find often they want to add this column up. But it's this one that we're adding up. And let me first do that. We write down the 3, then we add on the 5, we add on the 11, and we add on the 1. And before we do anything else, the first thing we want to check is that this total is the same as that total. Because we just added as we went, and they should match up. And of course they do here, so we're feeling confident. What does it mean? Well, it means the first 3 numbers are zeros. That's easy. What does the 8 mean? It means the first 8 numbers are 1s and 0s because we've added these together. So if I ask myself what was the second number, it would be in the first bunch of 3. It would be a 0. And I can see the second number is a 0. If I ask what the third number is, it's in that bunch, so I know it's a 0. If I say what's the 5th number, I know it's not in those 3, so it's not a 0, but the 5th number is in the first 8, so it must be one of those 1s I added on. And sure enough, 1, 2, 3, 4, 5, there it is. It's a 1. When I come to the 19, 19 represents all the 2s, 1s and 0s, because I've added these up. So if I ask myself what the 15th number was, it's not in the first 8, so I know it's not one of them, but it is in there, in the first 19, so it must be one of the 2s that I added. So this rather neat system allows me to identify the value of any number in any position in that list, which is rather neat. What's the 17th number? It's a 2. What's the 19th number? Oh, it's a 2. What's the 20th number? It must be a 3. It's the last one we added. So how do we find the median? Well, if there are 20 numbers, we would divide it into 10 and 10. I'm running out of space. I would have 10 numbers here and 10 numbers there, and I'll be looking for the gap in between. So I'd have my 1st, 2nd, 3rd, 4th, and my 10th number here, my 11th number there, up to my 20th. So I'm looking for my 10th and 11th numbers. Now we have a shortcut in statistics to actually locate that point. And what we do is we take this number and we add 1 and divide by 2 every time. So if it's 20, on the side, just somewhere on the side of the page, I get my students to do 20 plus 1 divide by 2. which is 10.5. And because 10.5 lies between 10 and 11, I know I'm after the 10th and 11th numbers. What's the 10th number? Well, it's not in the first 3, it's not in the first 8, but it is in this bunch. So I know the 10th number is a 2, and by the same reasoning I know the 11th number is a 2, because it's certainly not in the first 8, but it is in the first 19. So the median, properly expressed here, would be the mean of the 10th and 11th numbers, which are both 2. So I get my students to show that they've made that calculation, that they've averaged, to use the common word, they've averaged the 2s and got the answer 2. And you can see, in fact, that the mode, the mean and the median have come up with fairly similar numbers, and that's quite common. We usually expect the mode, the most common thing, to be sort of in the middle. Now, that's not always true with data, but with most large surveys that would be the case. And certainly the median's exactly the middle score, and the mean, well, you understand that. Average, adding them up and dividing gives you something in the middle. So 3 measures of middle spread plus the range. There they are, those 4 items, a column each, and I hope that overview has helped you to understand why you set a table out the way you do and what you're looking for. Now, in future videos, and I realise I'm covering I've got videos and all sorts of things that I have to complete, but in future videos I will show how to use this column to find the interquartile range. So we don't need an extra column for it. But we do need extra columns for the standard deviation. I will demonstrate at some point how to calculate that, although we do it on a calculator now. It's nice to do it manually once or twice, just so you understand what the root mean square deviation means or is. But to do it by hand, we really only use whole numbers, and that's not very realistic for real life, for most surveys. And also it's extremely tedious. So a calculator is a good option for the standard deviation, but it is nice to know where it comes from. In the good old days when I was at school, we had to do it by hand. But anyway, I'll also talk about the kinds of data that we get and how we can and can't analyse some. Sometimes we have to have a range of data in here, what we call a class, and that complicates matters a little bit. And sometimes we have what's called categorical data, and that affects what information we can glean from the table. But if you have numbers, simple numbers, that's the structure, 4 columns, 4 bits of information. I hope that's helped. And I thank you for watching, and please leave a comment, like the video and subscribe. Thank you.